Okay, welcome. This is 11.6. This is going to be part 2 and part 3 of optimization. Okay, so we'll start with part 2 first. So for the first 3 examples of part 2, they're all going to be related to a revenue function. We're going to have to create a revenue function from the given information. And then after we find the revenue function, we are going to optimize it, which means we're either going to maximize it or minimize it. And you know that process, all that means is to take the first derivative, solve for x, take that x value, plug it into the revenue function that we find, and plug it into the price function that we find. That's it. So I have the steps listed for the first example, which will be the same steps we use on the next 2 examples. So let's do it. Okay. Example 1. When a management training company prices its seminar, remove myself there, on management techniques at $400 per person, 1,000 people will attend the seminar. The company estimates that for each $5 reduction in price, an additional 20 people will attend the seminar. How much should the company charge for the seminar in order to maximize its revenue, and what is the maximum revenue? Okay, so here's where we start with step A. We're going to use the given information from the above, and it says set up an equation for price and set up an equation for the numbers of customers. So that's where we're going to start up first. Okay. Okay. So first thing we want, well, we're going to work these together actually. Price and then the number of customers, which these will go hand in hand. Okay. So let's start off again. The price of the management training company prices its seminar on management techniques at $400 per person. If it's $400 per person, 1,000 people will attend the seminar. So price is right now $400. And if it's only $400 per person, 1,000 people will attend the seminar. Now we need the next part. The company estimates that for each $5 reduction, what could represent the word each? And this means that every time we do a $5 deduction, right? So first times 5, next times 10, next times 15. So this means that for our price to represent that is going to be 400 minus 5x, x representing each time. Okay, and with that being said, for each $5 reduction in price, an additional 20 people will attend. So every time we do a reduction, 20 more people attend. So how could we represent 20 people attending each time we do a reduction? Well, that would be 1,000 plus 20x. That's it. There's price, and there's the number of customers. So that's what we needed. Using the information above, here's our setup. So we have price and the number of customers. Next is find the revenue function. All right. So revenue is always x times price, the number of items times the price we sell these items at. Well, here, the number of items is the number of customers. So I'll write that down. Revenue is going to be the number of customers times the price of the seminar. Whoops, I'm writing that in. You get it. Times the price of seminar. Well, we have all of that above, so plug it in. R of X equals 1,000 plus 20X times the price 400 minus 5X. Which means all you have to do now is FOIL. So 1,000 times 400. Don't want to miss any zeros, right? 1,000 times 400. That is 400,000. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. Good. Minus 5,000x plus 8,000x minus 100x squared. One more rewrite. And we have our revenue function. Highest power first. Negative 100x squared plus 3,000x plus 400,000. Oops. There's the revenue function. That's revenue. Okay. Then, after you find the revenue function, maximize it. Take the derivative. Set it equal to 0. Solve for x. We know how to do that. So, r prime of x equal to negative 200x plus 3,000. Set it equal to 0. Negative 200x plus 3,000 equal to 0. Solve for x. Negative 200x equal to negative 3,000. Divide by negative 200. Divide by negative 200. 3,000 over 200. 15. X equals 15. So what this number means is that, well, if we do 15 price reductions, then this could give us the maximum revenue, right? So this means that this is our critical number. And what this critical number means is that at 15 price reductions, we can get maximum revenue. So this is 15 price reductions. So if we reduce the price 15 times, then more people will come to our seminar and we'll still be rich. Okay. So now it says, use the answer we just found. Use the answer 15. Plug it into the revenue function. So take this value of 15, plug it into revenue, and plug it into the price equation. We can even plug it into the number of customers to see how many people actually come. Why not? Let's plug it in all three. Let's see what happens. So that's what we're going to do. Okay. So maybe I can fit it here. I'll say R of 15. I'm taking 15, plugging it into the revenue function, right? That's what this is. Okay. So that would be negative 100 times 15 squared plus 3,000 times 15 plus 400,000. And if we do 15 price reductions, this means we will make $422,500 in revenue. This is max revenue. Okay, and now let's plug it into the price equation. So for price, we have that equation up there, 400 minus 5x. So you'll get 400 minus 5 times 15. 400 minus 5 times 15, which means that if we do 15 price reductions, this means that the entry to the seminar is $325, which means we still make maximum revenue. So this is the price per seminar. And then I said plug it into the number of customers. Fair enough. Number of customers. And that is given by 1,000 plus 200 plus 20x. So you have 1,000 plus 20 times 15. 1,000 plus 20 times 15. And if we do 15 price reductions, then an extra 300 people will show up. So this means that you'll get 1,300 customers. And guess what 1,300 times 325 is? 422,500. So we didn't have to do the number of customers, but I did it just to show you that 15 is our critical number that will maximize our revenue function. And what was I going to say? I don't remember. Okay, let's move on. But this is the process you'll do. So for the next two examples, we will treat these as revenue functions. We're only going to be finding revenue functions. Even if it says, what's the income, what's the gross income, we are still treating it as revenue. Oh yeah, that's what I was going to remember to say. I was going to say, become a public speaker. You know, the guy who does like Rich Dad, Poor Dad, or those Ponzi schemes where you get 500 people to come to a convention at $500 a piece. Man, look at this number. You hold this seminar, you make $422,000 for that day for all those suckers. Yeah, so something to think about. That's what I was going to say. Okay. Number two, same kind of setup. A car rental agency rents 200 cars per day at a rate of $30 per day. For each $1 increase in the rate, 5 fewer cars are rented. At what rate should the cars be rented to produce the maximum income? What is the maximum income? So again, this is the same setup as the last problem. We're treating it as a revenue function, but we're going to call it income. Okay? All right. So our first step is to find price or rental rate, right? We'll say rate, find the rate, and find the number of cars. There you go. So we're going to say rate and the number of cars. Okay, so to start off with, we rent 200 cars per day at a rate of $30 per day. That's the first setup. So at $30 per day, 200 cars are rented. But now we decide to increase the rate by $1. So we need to represent every $1 increase. We're going to raise it $1 at a time. So that would be 30 plus 1x. And if we increase the rate by $1, 5 fewer cars are rented. So every time it goes up $1, 5 fewer cars are rented. So we need to represent that. That would be 200 minus 5x. There it is. There's rate, and there's the number of cars. 2. Find our income formula. Find income. We're looking for I of x. And like I said, we treat this like revenue. I of x is going to be the number of cars times the rate we rent our cars at. We have all that information above. Plug it in. I of x equals 200 minus 5x times 30 plus x. Once again, FOIL. You get 6,000 plus 200x minus 150x minus 5x squared. Then rearrange it, combine like terms. You get negative 5x squared plus 50x plus 6,000. This is our income function or equation. Okay, which means step 3, maximize income. And you know what maximize means. Maximize means to optimize, means to take the derivative, set it equal to 0, solve for x. We got that in the bag. I prime of x equal to negative 10x plus 50. Set it equal to 0. I prime of x equal to 0. Negative 10x plus 50 equal to 0. Negative 10x equals negative 50. Divide by negative 10. Divide by negative 10. X equals 5. All right. So 5 represents the number of rate increases we should do, right? So this should be the number of 5, so the number of rate increases. So we should only raise our rate by $5. That way we don't lose that many cars. Okay, so now you know what this means. This means take this 5, plug it into income, and plug it into rate. That's it, because it says at what rate should the cars be rented and what is the maximum income. So that's what we're going to do there. So for find max income and rate. So for this one, we're going to say I of 5 and plug it into our income formula above. So -5 times 5 squared plus 50 times 5 plus 6,000 gives me $6,125. This is max income. And then we want to plug it into our rate, which is above as 30 plus X. So 30 plus 5, we get $35. This is our rental rate. Our rental rate. Okay. So if we rent our cars for $35 per day, we'll still make a max income of $6,125. Now that's nowhere near as good as the seminar guys, huh? Maybe our car rental people need to go to that seminar, learn how to make more money. Okay, awesome. What would that be? 200 minus 5 times 5 times 35. Yes. If you plug the 5 into the number of cars that are rented at this rate, it would be 175 cars. Just in case anybody asks. Okay. Last one for these types of problems. Same way. Rental income. A 300-room hotel in Las Vegas is filled to capacity every night at $80 a room. For each $1 increase in rent, 3 fewer rooms are rented. If each rented room costs $10 a service per day, how much should the management charge for each room to maximize gross profit? And what is the maximum gross profit? So again, gross profit is the same as revenue. So that means step 1, we want to find our rental rate or our hotel rate. So this is step 1. Let's put it as the room rate. And of course, number of rooms. Okay, so to start off with, we have a 300-room hotel, and it is only $80 a room. So right here, $80 a room for the 300 rooms. Where are they staying at? The Flamingo, Circus, maybe even the Hooters Hotel. All right, so $80 a room, maybe Excalibur. I stay at Excalibur. Okay, so for each $1 increase in rent, 3 fewer rooms are rented. So to represent each $1 increase in rent, we say 80 plus 1x. And if we increase the room rate by $1, 3 fewer rooms are rented. So that would be minus 3x. Oh, right, these cheap people in Vegas, huh? Okay, but here's where they throw the curveball. If each rented room costs $10 to service per day, how much should management charge? So, do we pay for that $10 for room service, or do we make the guest pay for the $10 cleaning room service? We make the guest pay. We're not paying for that. So, guess what we're going to tack on to our room rate? A cleaning fee of $10. So this means our actual room rate is 90 plus X. There you go. That's how you run a business. All right. Cool. All right. Now, 2 is find gross profit. Find G of X. And just like the other ones, G of X is going to be number of rooms times room rate. And we have all that information above. Number of rooms, 300 minus 3x. Room rate, 90 plus x. Foil it. G of x is 300 times 90. That is 27,000 plus 300x minus 270x minus 3x squared. Simplify it one more time. Negative 3x squared plus 30x plus 27,000. Here is gross profit. There you go. Now guess what our next step is? Maximize gross profit. So take the derivative, g prime of x, which gives me negative 6x plus 30. Set gross profit equal to 0. Negative 6x plus 30 equal to 0. Then solve for x. Negative 6x equals negative 30. Divide by negative 6, divide by negative 6. And x equals 5. Okay, that is the number of rate increases. Now for find max gross profit. And rate. So take 5 and plug it into gross profit. Take 5, plug it into gross profit. Negative 3 times 5 squared plus 30 times 5 plus 27,000. I get $27,075. That is max gross profit. And then we want to find the rate, room rate, and our room rate was 90 plus X. So There we go. All right, that's the room rate. Okay, so if we put our rooms out at $95 a night, we'll still make $27,000 in gross profit or revenue, right? We'll still make that much money. Okay, there it is, not bad. All right, so that is part 2. So we just treat all 3 of these as revenue functions, and it's the same setup for all of them. Now we get into part 3, inventory control. Okay, part 3, inventory control. So let's go over some definitions, some labeling on when we're working with inventory control. X is going to be the number of items, like always. Y is the number of production runs to make X amount of items. X over 2 is the average number of storage each day. So the simplest explanation of where X over 2 comes from is, let's say, an Amazon warehouse. Or actually, now, a toilet paper warehouse, right? So one day, the store is full. The next day, the store is below half of inventory. Then, the next day, the store is full again. And then the next day, you're below half. And then the next day, you're full. The next day, you're below half. So no matter what, the amount of items you have each day is X over 2. So that's where that comes from. There is more of a detailed explanation in the book, but good luck trying to understand it. Just know that sometimes you're full, sometimes you're half, sometimes you're below half, sometimes you're full, below half, half, whichever. So that's what X over 2 represents. Maybe like your bank account, X over 2. All right, moving on. Next is storage cost. Storage cost is the cost to store times X over 2. Then everything will fine. Setup cost is the setup cost times Y. All this information will be given in the actual problem. So I'm just labeling everything how we set it up. The cost function for these types of problems, for inventory control problems, is given as storage cost plus setup cost, which we see above how to set up. Demand equation, which is also given in the problem, is known as X times Y equals the annual demand of items. It's the number of items times the number of production runs, and these are the demands that people want these items. Okay, so let's go ahead and read the problem and see how to set this up. A multimedia company anticipates that there will be a demand for 20,000 copies of a certain Blu-ray during the next year. It cost the company 50 cents to store a Blu-ray for 1 year. Each time it must make additional Blu-rays, it costs $200 to set up the equipment. How many Blu-rays should the company make during each production run to minimize its total storage and setup costs? Okay. So the first thing we want to find is storage and setup costs. Well, storage, which you see right up there, is the cost to store times X over 2. So storage costs, let's start with that. And from the problem, storage cost is the cost to store, right there. It costs the company 50 cents to store a Blu-ray. So storage cost is given as the cost to store, which is 50 cents, times X over 2, which means this gives me 0.50X over 2, or what's half of 50 cents? That's right, kids, 25 cents X. So this is storage cost. Now, let's find setup cost. Setup cost is the cost to set up times Y. Well, there it is again. It costs $200 to set up the equipment. That's it. So setup cost is 200 times Y, or 200 Y. Now, let's find the cost function. Cost is given as storage cost plus setup cost. Do we have those? Yes, we just found those. So that's what B is. B says, let's find our cost function, and cost function is given by storage cost, which is 0.25x, plus setup cost, 200y. There it is. Okay, now let's find the demand equation. And then after we find the demand equation, we are going to rearrange it, solve for y, and plug it into the cost equation. But let's get the demand equation first. So demand is given by x times y equals the annual demand. Well, look at the problem. There is a demand for how many Blu-rays? 20,000. We have our number. So, with that being said, we come down to demand, and the demand equation is given by x times y equal to, and the demand for these Blu-rays is 20,000. There's demand. Now, what we're going to do next is take this demand equation and rearrange it in terms of y. So, x times y equals 20,000. I want to solve for y, so I'm going to divide by x, and this gives me y equals 20,000 over x. Or even better, 20,000 x to the negative 1. Now, just like this step says, we are going to take 20,000 x to the negative 1 and plug it in for that y value. That's what we're going to do. We're going to plug it in for y in the cost equation. So that's what's going up next. So we're going to have C of x equals 0.25x plus 200y. We plug this in for y, and you'll have C of x equals 0.25x plus 200 times 20,000 x to the negative 1. Let me zoom in. I can fit more stuff if I zoom in, which means simplify that, and we get C of x equals 0.25x plus 200 times 20,000 which is 4 million. X to the negative 1. This is our new cost function, all in terms of X. This is cost in terms of X. Okay. And now, D, minimize the new cost function. Take the derivative, set it equal to X, solve for 0. That's what we're going to do. So that's step D. And I'll make use of my space. So we're going to say C prime of X, and we're taking the derivative of this one. 0.25x plus that, okay? So let me put that, I'll draw you a nice little green arrow. We're taking the derivative of that. Okay. Which means that I should have, let's see, 0.25 minus 4 million x to the negative 2, right? 0.25 minus 4 million times x to the negative 2. Now, you know what's next. Set it equal to 0. 0.25 minus 4 million x to the negative 2 equal to 0. I then will move that over. So this would be 0.25 equal to 4 million over x squared. So all I did here was take this x to the negative 2 and flip it to the bottom. Remember, negative exponents can flip. And then I will cross multiply. I'll put this over 1 and cross. So this becomes 0.25 x squared equal to 4 million. Then I'll divide by 0.25, 0.25, and 4 million divided by 0.25 is 16 million. Ooh, big numbers, huh? But now we will square root. And I will get x equals plus or minus 4,000. So now, remember, x represents the number of items. So can we have negative 4,000 items? No. We only take the positive value. So this means that x is 4,000. And this is the number of items. So in order to minimize our costs, this means that we have to produce 4,000 Blu-rays. So this is the number of Blu-rays. Okay. So what we're going to do next is solve for y. That's the next step. And we're going to solve for y because we already created an equation for y. We are going to use this to solve for y. Y equals 20,000 over x. So there's my next step. I'm going to say solve for y when x equals 4,000. This means that using that equation above, you have y equals 20,000 over x, which gives us, I'll just keep going below, save space, y equals 20,000 over 4,000, which means 20,000 over 4,000 is just 5. Now, remember that y is the number of production runs. So if we are going to, let me show both answers here. If we are going to make 20,000 Blu-rays for the year, we need to do 5 production runs. And in each production run, we need to make how many Blu-rays? That's right, 4,000 Blu-rays. Because 5 times 4,000 is, guess what? 20,000. So every time we do a production run, we make 4,000 Blu-rays. So this is number of production runs. Okay. We have one last step. Plug x and y into the original cost function. Because in the beginning, we want to know what's it going to take to minimize our costs. Okay? We want to know what's it going to take to minimize our cost. So we're going to plug x and y into the original cost function, which is right there. So let's do that. And right here, make this a step. We'll say plug x and y into C of x. The original C of x, right? So I'll have C of 4,000, comma 5 equal to 0.25 times 4,000 plus 200 times y. Well, how about this? Even better. Plug this into 0.25x plus 200y. And that shouldn't be a y down there. That should be a 5. Okay, and then we get that cost at 4,000 Blu-rays and 5 production runs is going to be $2,000. I I believe this is the minimum cost at each production run. The minimum cost at each production run. There you go. That's the setup. Woof, that was fun. So many emails. Stop it. Okay, cool. Let's finish this. Ooh, we're almost there. Ooh, all right. So the next one, we're going to handle the same way. So a tool company has a uniform annual demand for 9,000 premium chainsaws. It costs $5 to store a chainsaw for a year and $2,500 to set up the plant for manufacture of the premium model. How many chainsaws should be manufactured in each production run in order to minimize the total storage and setup cost? Okay. First thing is find storage and setup cost. So that's where we begin. 1, storage costs. And then setup costs. So storage costs, right there above, costs $5 to store a chainsaw. So that's given by 5 times x over 2, or 2.5x. Setup cost. It costs $2,500 to set up the plant. So that is 2,500 times y. So that's 2,500 y. All right. 2. Let's find the cost function. And let's find the demand function. Find cost function and demand function. So cost function is given by storage cost, 2.5x, plus setup cost, 2,500 y. There's the cost function. Demand is given by x times y. And how many chainsaws are demanded? 9,000. So demand is 9,000. All right. So step 3. Rearrange demand, solve demand for y, plug it into y in the cost function. So what's the easiest way to make this step? I'll just say rearrange demand, solve demand for y. How's that? So that's where we'll begin. Demand is x times y equals 9,000. Divide by x, divide by x. Y equals 9,000 over x. Or even better, y equals 9,000 x to the negative 1. Now 4. Plug, or how about sub y into cost function. So C of x equals 2.5x plus 2,500 times 9,000x to the negative 1. 2.5x, 2,500y, 2.5x plus 2,500y. Simplify. C of x is 2.5x plus 2,500 times 9,000. That's like 225 million or something like that. Let's see what my good old calculator said. 22,500,000. 22,500,000 x to the negative 1. Okay? Now, 5 is minimize. Minimize C of x. We still got a lot of room. Okay. So minimize C of x, we get C prime of x equals 2.5 minus 22,500,000 x to the negative 2. Then set it equal to 0. 2.5 minus 22,500,000 x to the negative 2 equal to 0. Add that big terrible number over to the right. 2.5 equals 22,500,000 over x squared. Again, just get that negative exponent, flip it to the denominator, then cross multiply, and you get 2.5x squared equals 22,500,000. Divide by 2.5, divide by 2.5. X squared equals 9 million. And then you know we will square root, and x equals plus or minus 3,000. But remember, we only take the positive one, so x equals 3,000. So 3,000 is the number of chainsaws. Now, where's all my room at? 6, solve for y. So I'll start here. 6, solve for y when x equals, what was it, 3,000? And we'll use the equation for y. Y was what? 9,000 over x. Okay. Y was 9,000 over x, or 9,000 over 3,000. And y equals 3. This is the number of production runs. So if we do 3 production runs, every production run will make 3,000 chainsaws to reach our annual demand of 9,000 chainsaws. Yeehaw! And now 7 is plug into the cost function. right? We want to minimize storage and setup costs, so just plug it into the cost function. So 7, line that up a bit. 7, plug x and y into c of x equals 2.5x plus 2500y, right? Was that the original cost function? Yes. So, with that being said, you get c of 3000, comma 3 into 2.5 times 3000 plus 2500 times 3, and C at 3000 chainsaws and 3 production runs, 2.5 times 3000 plus 2500 times 3. Each time we do a production run, we will have a minimum cost of $15,000. Woo-wee. That is it. Okay, awesome. That is optimization part 2 and 3. Not bad. All right, that's it.